Good morning, Algebra 2. We are going to do lesson 80, which is finding normal distribution. So this is a stats lesson, actually. It's not difficult. It's just explaining the pieces. So I want to start with what a normal distribution looks like and remind us of some symbols. So when you see X with a line above it, remember that means mean, which is also our average. And then standard deviation, I use the acronym SD for that, so we're not having to write it over and over and over. But it's also, another symbol for it is almost like the theta symbol. So here's a normal bell curve. Now in a normal bell curve, right down the middle is your mean. Okay, so right down the middle would be the average. So let's say average test score or average height or average weight. Right in the middle should be your mean. To the right, you have three sections. The first is +1 standard deviation. The next is +2 standard deviation. And the next is +3 standard deviation. Remember, standard deviation is like the average distance away from the average height. So and I'll explain that in the next example, but this is the chart that is drawn in the book. So starting from the middle, we should have 3 matching divisions on the left. And to the left, we are subtracting a standard deviation each time. Now, percentages of the population or people is then included in each bracket. So from the first bracket to the left to the one on the right, that would be 68% of your data. So each of these, this is 34% and this is 34%. So if you add them together, that whole section, and I'll extend this, is 68. Now, if you go out another bracket, this is 13.5%, and to the left, this is also 13.5%. So from the second bracket to the left to the second bracket on the right, that represents 95% of our data. And then working out, this is just 2.35%. 2.35%. From the third bracket out to the left to the third bracket to the right is 99.7% of your data. Almost 100%, but that accounts for if there is an outlier. So, standard deviation is the distance from your average. And so I'm gonna do one with you, and then we'll get into the lesson practice. So let's pretend that the average height in our class is 5'7", okay? And that the standard deviation is 3.6. So meaning it varies 3.6 inches in each direction. So the first thing I need to do to build my bell curve is I'm going to convert this height to inches. So 5 feet 7 inches is 67 inches. That way both our standard deviation and our average is in inches. So I'm going to build a curve and then we're going to analyze the data. So that was a terrible one. So right down the middle would be 67 inches. And then going to the right, we're going to add our standard deviation. So 67 plus 3.6. Gives me this next category of 70.6 inches. Then I'm going to add another one, so plus 3.6, and I get 74.2 inches, and one more, plus 3.6, and I get 77.8 inches. Okay, now going to the left, we're going to do the exact opposite. We're going to subtract. So go back and enter your mean, 67, and then subtract a standard deviation. So this is 63.4 inches. Subtract another 3.6. This is 59.8 inches. This is 56.2 inches. So based on this data, 68% of people are between what height? So, I know that the first bracket to the left and the first bracket to the right represent the 68% of people. So I would say 68% of people are between 63.4 inches and 70.6 inches. Next one, 95% of people would be between this next bracket. So 59.8 inches and 74.2 inches. So 95% of people in our class are that height. We're just saying, we're guessing. Okay, and then last, the 99.7, that's the last bracket in each direction. So it's in between 56.2 inches and 77.8 inches. Okay, Z-score. Now, Z-score is something different. The Z-score is the number of standard deviations away from the average that a data point represents. So I've written down the formula for your Z-score. It's your data minus the mean divided by your standard deviation. So we're going to do two examples using the same data. So we're using the mean is 67 inches. The standard deviation is 3.6 inches. So 5'7" is the average. So if you are 5'4", how many standard deviations away from the class average or from the mean are you? So to find how far away, how many standard deviations away, you would find your Z-score. So first I have to convert this to inches, right? 5 times 12 plus 4 equals 64 inches. So our 64 inches minus our mean divided by our standard deviation. So 64 minus 67 divided by 3.6, and I get negative 0.83, and the 3 repeats. So because it's negative, I would say this is negative 0.83, standard deviations below, because it's negative, the mean. Next, if you are 6'3", how many standard deviations are you from the class average? So first, let's convert this to inches. 6 times 12 plus 3. So 6 times 12 is 72. 72 plus 3 is 75 inches. So your Z-score is 75 minus the average divided by the standard deviation. So 75 minus 67 divided by 3.6, and I get 2.22 standard deviations. Now, because this is positive, I would say standard deviations above the mean. And it's above because it's positive. So those are some examples. We're now going to practice that in our lesson practice. So the lesson practice is on page 568. For parts A through D, they ask us to use the following. Our mean is 300 and our standard deviation is 18. So part A asks us, let me look at the back, between what two scores is 99.7% of the data? Now you can build a curve if you'd like, or you can try to picture it by hand. But the mean would be in the middle, so 300, and then 3 to the right, 3 to the left. So this would be 318, 336, 354. Subtract 18, that's 282, 264, 246. So if that helps, you can build that, or you could just add 3 18s and subtract 3 18s. It's totally up to you. But the answer to this would be between 246 and 354, because the 99.7% is the third on the left to the third on the right. So these two numbers here. All right, part B says, sorry, the book's right here. What percent of the scores? What percent are between 264 and 300? So it's asking from here to here. Now I wrote in our notes that this section here is 34%, and this here is 13.5%. So I'm going to add those up. So 34 plus 13.5, I get 47.5%. Part C asked what percent is between 282 and 336. So, sorry, I should have highlighted this. 282 and 336. So that would be the 68% in the middle plus 13.5%. Wait, 282 to 336. Oh yeah, that's it. And that would give me 81.5%. And then part D, what percentage is in between, what percent are greater than 318? Okay, so after 318, this section right here is 13.5%. And this last one I wrote down was 2.35%. If you're wondering where I'm getting these numbers, it's from that first one I drew. See, those little percents are drawn. And if you add those two together, the percent is 15.85%. So moving on for parts E through F, they want us to use a mean of 12.2 ounces and a standard deviation of 0.08 ounce. So part E wants us to find the standard deviations if you weigh 12 ounces. So Z equals 12 minus our mean divided by our standard deviation. So 12 minus the mean divided by 0.08, and I get negative 2.5, and because it's negative, we would say below the mean. Part F, the data point is 12.3 ounces, so Z equals our data minus the mean divided by our standard deviation. And I got 1.25, so because it's positive, I would say it's 1.25 standard deviations above. And I'm going to stop there. So G is kind of redundant. For homework, we're going to skip numbers 6, 8, 16, 17, 22, and 23. Thank you.